All right, welcome to. Let me check if my stream is running. Um, just gotta keep this going. Yeah, yeah, yeah. Oh no, not that. Let me check if my stream is running. All right. I think we're good. We're good. We're good to go. So, started studying about linked lists yesterday, and it has been a pretty good start. Although I didn't cover much yesterday, but today I'm planning to do that and just cover as many, um, at least as um, from a beginner's point of view, right? The necessary things we need to know about linked list to get started. So let me um, let me put this down. Right. So I'll have my linked list. Yeah, so this is I left the link to this resource in the description. I've been reading about linked list. Yeah. So, well, let's. I'd just like to go over the things I've read about linked list and how it works. So the first type of linked list I studied is the singly linked list, right? So it's just the normal linked list. And a linked list is a fundamental data structure in computer science. It consists of nodes where each of each node contains data and a reference link, right, to the next node in the sequence. So a reference, which is a link to the next node in the sequence. This follows the dynamic memory allocation and efficient insertion and deletion operation compared to arrays. And I will do that comparison here to actually, clarify that indeed, um, linked lists are much better than arrays, right? But when you try to see what a linked list actually is, it's just a series of nodes connected, and the nodes are basically a class, right? So here's an example of a linked list. I'll just come here and let's scroll to I think it should be here. Yeah, the operations on linked list, right? All right. So, and I'll use this to explain clearly what happens. First of all, to begin a linked list, right? We said linked lists are a series of nodes, right? So let me just come to my board here as usual and try to represent, you know, the linked list visually. So linked list is a series of nodes, right, connected um, from one end to the other. So let me just come here. So here's an image of a linked list, but I'll just I'll just um so let's just do it this way. I'll represent, a linked list is made up of nodes, right? And nodes are basically, you know, um objects that have a value and a reference link, right? So I'll represent my linked list like this, right? Let's just represent a series of blocks, and these blocks will represent our nodes, right? Our nodes, and you know, so the node itself will contain the data, and then the next node, right? The next node. So this is a reference to the next node, which is this node here, right? Let's call this. I'm just going to represent. Okay, so let me. Oh boy, So let me start. Let me start with this. I'll use a different color to represent my nodes. Right. These are my nodes. I'll just put them like this. I'll create three nodes. Three nodes is okay. At least for with three nodes, I can explain this properly. Now each node is connected to the next node, right? Now, how does this connection happen? Well, this connection happens with the fact that each node itself, right? I'll call this node A, this is A, B, and then C, right? Each one of this node, each one of this node has something called the data, which is the value of the node, right? So we'll have the data, I'll call this data, right? And then the next, right? The next is simply the next node after it. Now, in every linked list, the first node that we have in a linked list is called the head. This will be our head node, right? This is the head node, and every other node is just tied to the head, right? And then the following one and so on. Now, the last node in a linked list, right, is going to be tied to none, right? There's no item after it. There's no node after the last node in a linked list. So always a linked list will start with a head, right, and end with a non-linked non-node, right? A non-node. A non-node is just empty. All right. So where do we go from here? Like, how do we even dig deep to understand what this linked list is all about? Well, first of all, let's go back a bit and look at arrays, right? So arrays are just like linked lists, but with I would not say, well, arrays are just like linked lists, but with a very few difference in terms of performance, right? So for instance, every item in an array is arranged in a contiguous sequence, right? So let's say we have an array called names, right? Or I would just call this noms, right? Noms. And this is an array of numbers 1, 2, 3, 4, right? Now, this array has a fixed size, right? And the last item in an array, right, is found at a particular position. So every item in an array, every item in an array, right, like this 1, 2, 3, right, appears at a certain address, right? And the address are represented differently to us, for us to use in terms of programming, right? And these are called indexes, right? So we'll start from 0, 1, 2, and then 3. But in the case of linked lists, we don't have indexes, right? We don't have indexes. So when you access an element in a linked list, right, let's say for the head, right, for you to be able to get the node C, right, you have to go through the node B by accessing the item, the node beside the first node, which is the head, and then you look at this node, which is the node B, right, and then look at which item is on the next side of it, right? So like I said, every node has a data, which is the value of the node. In terms of arrays, right, in arrays it's just the values, right? It's just the values. And in linked list, it could be the same, right? The data could be editing from being alphanumeric characters or anything essentially, right? But when you come to accessing positions in linked lists, we don't really have position, but we have nodes pointing to the next node, right? So the next, right, is simply a node itself, right? The next is simply a node, and you can access the next node through the next value of its preceding node, right? So in terms of arrays, to get the last any item in an array, you have to know its index. So let me go over that again. I'll erase this and start over afresh. uh so let me just see if my if my stream is going on well. Okay, it is. So, let's start over again. So, linked list, right? Linked list is just items arranged in a sequence, but this time around, not like the way items are arranged in an array. In an array, right? I'll call this array nums. Let me use a different color. I'll call this array nums, right? Let's just start with arrays to properly understand what's going on. We have numbers from 1 all the way to like 4, right? I mean, so this array has a fixed size, right? The length of this array will be 4, right? I mean, it's not because the last item in the array is 4, but to get the length of the array is basically how many items are in the array. So the length of this array is going to be 4, right? And to access any item in this array, right, we need to know the item's index, right? To get the second element in this array, which means item at index 1, right? Because we start counting items from 0 all the way to the last item. So this will be 0, 2, and then 3, right? So the second item in this array is 2, which is at index 1, right? And this is basically stored at a particular address in your memory, right? In the memory of your computer. So you can append more items to an array, right? You can append more items to an array, and that will simply take a constant time operation, right? It's a constant time operation to insert an item into an array. But to insert an item to the front of an array, that becomes a problem, because now we know we can only insert an item at the back of an array. But if we were to insert an item at the front of an array, we then need to rearrange the index of each item in the array, right? And this will take us O of n time to compute or to perform this operation, right? So yeah, and that also goes for inserting item at a specific index. Let's say we want to insert an item at this point, right? We would then need to rearrange every item in the array, right? We'll then need to arrange every item in the array in order for us to do that. By rearranging every item in the array is basically to change the index of every item. So let's say, for instance, we want to insert 0, right? 0 here in this array. I'll quickly erase everything, right? We want to insert 0 in front of 1 inside this array. For us to do that, then it means we will then rearrange everything, which means 1, which used to be here, right? This used to be 1. Sorry. This is 1 used to be at index 0. This is index 1. 2 was at index 1. 3 was at index 2. 4 was at index 3, right? Now, which means we will inserting 0 in front of this array, or setting 0 as the first item in this array, means putting 0 at index 0, right? So for us to do that, we will then increase the array and then shift every item, right? So 4 will appear at position 4, and then we'll have a 3, we'll have a 2, we'll have a 1, and then we'll have 0. And when you look at this again, this becomes 0, 1, 2, 3, and 4, right? As you can see, this is a very time-consuming task or time-consuming operation, because now we have to shift every item in order for us to insert them into our array. And this is not really efficient, right? So the same thing goes for inserting in the middle, right? How do we insert an item in the middle of an array? First of all, we also, since we are inserting an item, it means our array will increase in length, right? So if our array was originally of length 4 and we want to insert 5 somewhere here, right? Or let's say want to set 5 between 2 and 3, right? So this is how we'll do it. We'll first of all increase the length of our array, right? This will be 1, 2, 3, 4, 5, right? Now this is the length of our array. Now we'll begin to, um shift every item up to the position where we want to insert um our value, right? Our new value that we want to introduce to the array, and then we now put the value there and rearrange everything all over again. So let's say we want to insert 5 at position 2, right? So meaning 5 will appear somewhere here. So for us to do that, we have to make space, right? We have to change the index of each item. So here's what we'll do. We'll first of all start here, right? We'll first of all go 1 and then 2, right? Yeah, 1 2, because this is 0, which item is at 1, so this will be 2, and then we want to insert 5 at position 2, right? So position 2, so 5 will appear at position 2, which is index 2, right? This is 0 1. Okay, so at index 2, we want to have the value 5, right? Which means what was here before will shift away from its position to the next position, right? So this will now become 3, and then this will be 4 here, right? Now you can see, we shifted each item, changed their index in order for us to, perform this insertion at a specific position in an array. But it's setting at the end of an array is constant, right? It's O of n operation, because we know the end of an array is just the end, is the last item plus a new item. So that is not really time consuming or consuming space. It's just a basic operation that we can perform with arrays, right? So but when we try to optimize arrays, right, we get introduced to linked lists, right? Linked lists are basically like arrays, but this time around, instead of storing items at indexes, right, linked lists uses something called node, right? Node are the fundamental basics of linked list, right? Every item in a linked list is a node, but the first item in a linked list is called the head of the list, right? It's called the head, and every item, the head points to a second node, right, called the next, and then the next, which is the second item, the item after the head, also has a next value, which is the following node, right? So here is a representation of how that is. I'll just represent the linked list with a different color. I'll use, okay, so let me use a white color here. So we have a linked list like this. So it's going to be an item pointing at a different item, right? And then going forward all the way to maybe, let's say, the last item in the node, right, has to also point at something. But if there's nothing else after it, then it points at something called the none, right? This is going to be none, right? This means it points at nothing, so there's no item after it. But if you want to insert an item, we can still do that. We'll simply take the next value of this, right, and then replace it with the new item that we are introducing in the linked list. So here is what a linked list will look like. I'll just represent, here's what a node, right? Each one of these are nodes, right? So this is a node, this is a node, and same thing for this one too. This is also a node, right? And this too is a node. So each item in a linked list is a node. And what is a node? A node is basically a class, right? Or like I said, the basics of linked lists that contains, first, number one, the data, right? I'll just put this. Sorry, I'll just say, okay, let me remove this. the node contains the data that we want to store, right? So this will be the data, and the next, right? The next is simply, the next node, right? Which is this one here. The next value of this node here, right? I'll call this A, this will be B, and this will be C. The next value of this, A node is this B here, and the next value of this B node is this C node here. And each one of these things are, in form of code, are represented by classes, right? So we have our linked list, right, in this form, right, arranged in sequence. The first item in a linked list is called the head, right? This is the head of our list, right? And the head starts, as the single item in the list, right? So when the head is introduced in the linked list, it's going to have a net value of none, right? Because at that point we've not introduced any item yet in the list. So at the end of the day, if we were to start a linked list, let's say we start with an empty value, our linked list would look like this. It will be empty at first, but when we insert, a node, let's say a node which has value, like, so the data will be 1, and the next value, right, the next value automatically is a none, right? It's going to be none, right? It's going to be none because the first value is literally not pointing to anything at first. So when we initialize our linked list, right, I'll call this linked list, let me just say LL, right? This is our linked list. When we initialize our linked list, at first it will have a head, right? But the head will be empty, right? We will not have any value as our head. So basically the head of this linked list, right? This linked list is going to be equal to none, right? We will not have any value at first, but when we begin to insert items in the linked list, right, things begin to change, right? So every linked list, when we begin to introduce nodes into our linked list, everything begins to change, right? So we will then have, new nodes that are part of our linked list, right? So let's say we are introducing this first node here, right? Like I said, the data is going to be equal to 1, and the next value here we don't know yet. We will not know what the next value is until we insert it into the linked list. And when we insert it, we will then find if there is any item existing in the list, right, previously, before our introduction of a new node. If there isn't, then the new node we insert into this linked list is going to be our head. So in this case, we have a node that has data 1 and a nest of none. And initially our linked list was empty, right? So let's say we do linked list dot let's say add this node here. Let me just erase this and write it properly. I'll just create a new node, right? A new node with values in it. I'll call this node, right? Node is going to be equal to so the data is going to be equal to 1, and the next value, right, next is going to be equal to none, right? Because I mean, it has to point to something for it to have a value, but since it doesn't have anything here yet, then we can't give it a value. So instead of calling this node, I'll call this new node. I'll just say n node, right? This stands for new node. So let's say we want to introduce this new node into our linked list here, right? So we'll basically do, which means we are adding the data to this linked list, right? So first of all, we are adding 1 to the linked list. Let's say we add 1, right? So 1 as our value, right? Sorry. When we insert 1 to our into our linked list, right? It means we want one to be the head of our list, right? Because initially this linked list was empty, so we want one to be inserted. So when we insert one, we'll transform one into a node like this by changing, by instantiating a node, by transforming it to a node. A node is basically going to be a class with these two properties, right? We have the data and the next property. The next property is basically the next node after this first node that we are introducing. But since we are introducing the first node, right, we first of all need to check, okay, if does this node have a head, right? If this node indeed has a head, then our new node, right, is either going to be the node after the head, or the node, after a node connected to the head, right? Like in this case now, just imagine this one we are inserting here is equal to this a here. A is equal to 1, right? This is our first node that we are introducing to this linked list. But at first we will not have this item because we've not introduced them yet. So this node here will point at none, right? This node will point at none at first. So when we set our one value into the node by calling this add, this will basically be a method of this linked list class, right? So when we set one into the linked list, then one becomes our head, right? It becomes the head of the node. So we'll set this head, right, this head to the new node. I'll just say head head will become 1, right? This head will become 1, and the next value of this one, right, because this one here is basically a node, like I said, this node here with the data equal to 1, and the next value is going to be equal to none, right? So when we add an item to this linked list, right, it means we are transforming. When we add an item to this linked list, when the head is empty, right, it means we are introducing a new node as our head. And sorry for the mistake I made here. The head is not going to be equal to 1. Instead, the head is going to be equal to a new node, right? So it's going to be a new node, right? Let me just represent it by an object, right? So this is going to be data, right? Data is going to be equal to 1, and then the next value here is basically going to be equal to 0. It's going to be equal to none because we don't have any items yet in this linked list. Now, and so that's it. We inserted our first item in the linked list, which is the head. Well, imagine when we want to add more items to this list. What then happens, right? So to do that is basically simple, right? So first of all, let me change this color. So let's say we want to add another item to our linked list, and we'll say linked list add, let's say add 2, right? Now what happens in this case? First of all, well, we are introducing a new item to our linked list, which means we are introducing a new node. Like I said, a linked list is just a collection of nodes, right? And a node has the data and the next value, right? So for us to be able to do this, we first of all need to know if our list already has a head, right? And we know that by just seeing this, because we inserted 1 into our linked list previously, right? So 1 is now our head, right? Or no, 1 is not our head, but it is the value of our head. So the data is here, and then the next value is going to be none. So 1 was formed. 1 was used to form a node, which was our head, right? So we need to first of all verify if we already have a head in our linked list, and then we'll take the new value that we are inserting into this, right, into the linked list, and add it as the next value to our head, right? So how do we do that? First of all, we know we need to create a node from this value that we are inserting into the linked list, right? So this is going to be a node, a node. I'll just call this a new node, right? NN node, and say this is equal to data is going to be equal to 2, and the next value, right, as always, is going to be none first. Now, what do we do with this? Well, first of all, we need to check if we already have a head in our list list, so that we don't introduce this new item, which is 2 new value as our head. Well, instead we need to set it as the next value of our head, right? So how do we do that? Well, we also need to check if there is a head. Of course there is a head, right? But does this head have a next value? No, this head does not have a next value. So what do we do in this case? We simply just take this head, right, and set its next value to our entire new node here, right? So here's what we're going to do. We first of all need to check if the head has a next value, right? If the head has a next value, we first of all need to check, from the base, right? We need to check if we already have a head. Of course we have a head now. Does our head have a next value, right? Does our head have a next value? Yes, our head has no, sorry, no, our head does not have a next value. So we set our newly created node as our next value for the head, right? So it's going to look something like this. So it's going to be head sorry, what am I swear, head dot next, right? Because every node, every item inserted into the linked list is a node, right? So head dot next is going to be equal to, it's going to be equal to our node here, our newly created node. I'll just represent this by this, right? Our newly created node. And this, to visualize this, right? So in the first step we had something like this. We had a head in our linked list, right? The head has a value of 1, right? And the next value is equal to none, right? It wasn't pointing at anything. But in the second iteration, so let me say ll add 1, right? But in the second iteration, right, ll add 2, right, something else happens, right? So we know we already have a head. So here's what we are going to do. We're just going to take that head, right, which was pointing at none, right, and attach and replace this non value. This non is also the next value, right? And replace this non value from our newly created node. And we know when we add an item, we create a node from it first, right? I'll call this new node, right, nn, and this will be equal to data equal to 2, and then the next will be equal to what? It will equal to none, right? This here will be equal to none, and then we'll take that value and append it to this way. So it's going to look something like this, right? It's going to be a node itself with a value or a data equal to 2, and then the next value is going to be none, which is this none here, right? So that is how we create a linked list. And every time we insert an item into the linked list, we will do that, right? We'll simply take the last value that was in the linked list just by traversing the list, right? So let's say we want to add another item to 2, right? Let's say we want to insert a 3. So I'll say ll add. Ll stands for linked list, right? So don't get confused, this is not a special function. But let's say ll add a 3, right? So in this case, what do we do? First of all, we need to check if our linked list has an item, right? So if our linked list has a head, so that we don't mistakenly replace the new list with a head, the new node as the head. So we'll then first of all we'll check, yes, we have a head, right? The head has a next value, right? So we'll take that next value again, right? This is going to be pointing at none, right? So how do we insert 3? How do we insert 3 in this list, right? This is our newly formed linked list, or our previous linked list to say. So to insert the new value, the new node that we want here, I'll call this I'll call this n3, right, which is, node of 3, right? This will have a data is going to be equal to, sorry, the data here is going to be equal to 3, and the node, the next value, right, is always going to be equal to none, right? It's always going to be equal to none. So how do we insert or append our next value, or insert 3, our next node, into this formed node here? First of all, we need to traverse from the head, right, and get the next value at each point. So we'll first of all check here, right, this head here. Does this head have a next value? Yes, the next value here is equal to this 2 node here, right? Does this 2 here have a next value? Then we'll also look at it. And in the case where we don't find a value or a node after the node we just checked, then we'll know that this is the position where we need to insert our new our new our new node to be introduced in the linked list. So here's what we need to do. So at the end of the day, we'll have 1 pointing at 2 here, right, and then 2 pointing at 3, because this is the position where we found a non-value, right? And when we find a non-value, we'll then replace, or we'll then insert at that position the new node we want to insert, which is of value 3. The node will have data equal to 3, and the next value is going to be equal to none. Again, this will be 3, and then the next value here is going to be equal to none. And this is how we'll insert an item in a node, in a linked list, right, every time. So we are just appending an item wherever there's a non-value, right, or the last item has a non-value in the linked list. Of course, this is just an overview of what happens with linked lists. There's still more to do, but I just want to really cover my understanding on linked lists based on my findings. And also uh oh, somebody is in the chat. Hi, welcome to the chat. Right. Okay, so um yeah, compared to arrays, right, and the insertion at the end of a linked list is pretty much going to be the same, right? It's just going to be constant. But in this case, I think this will take O of n, because we have to travel, every node, right? Every previous node, um, until we find a node where there was no value, right? And then we'll now insert an item at that point. But just um yeah, that's adding an item at the end of a linked list, right? So it's just going to take us O of n time, because we need to traverse as many elements or as many nodes there are in the linked list, in order for us to get to a point where a node has a next value of none, right? And then we will know that is the last node in the list, and then we will now insert a new node at that point. And that new node will also, will ultimately have, a none as the next value. Now, let's say we want to insert an item at the beginning of a linked list. Now this is going to take O of 1 time. It's going to be constant, because now we already know what our head is, right? We can access the head of our node at every time. So at any time, sorry. So to insert a new item, or to place a new item at the beginning of our linked list, we simply need to take that item and replace the value of our head by that value, right? And yeah, so that item becomes the new value, and automatically everything shifts, right? We don't even need to shift, because we know already, right? We know already that our linked list, right? Sorry, our linked list has a head, right? And every item is connected, right? Is connected to another item in the linked list. So if we're replacing our head with a new value, let's say we want to insert a zero at the beginning, right? So I'll say ll add 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 at add at start, right? Add at start, right? Add at start 0, right? This 0 here will form a node, right? A node with data equal to 0. So the data will be equal to 0, and then the next value here will be none, right? Next value here will be none, right? Will be none. But since we are inserting it at the beginning, the next value here will point at our previous head, right? So here's how we'll do it. We'll simply take our new node, right? We'll simply take our new node, right, and replace the value of the next its next, right? So this will have a next value. So let's say this will have a next value of none. So since we want to insert it at the beginning, we'll simply replace this none with the head value here that we have here, right? So the head here is from 1, right? 1 pointing to 2 and so on. So yeah, we'll simply have 0, right? We'll have 0 pointing to our head, which was, the next value, which we simply just need to change the next value here. Meanwhile, in arrays, we have to change every index at each point. We have to change the indexes of each item, right? We need to rearrange everything in order for us to insert an item at the beginning. And I'll show you how the insertion of item works in an array. I've not fully covered linked lists in terms of coding, but I just needed to really understand the concept behind it first. So the new item we are inserting at the beginning will simply have a next value of the head that we had previously, right? So this is going to connect to this point. So instead of this having next of none, right? Instead of this 0 here having next of none, we simply need to change it to the value of our head, right, which is going to be equal to 1, and this head will continue pointing at every other thing, right? 2, and then 2 will point at the node where 3 appears, and 3 will be equal to none, right? This is the basic operations that you perform with linked lists, right? This is how linked lists work, like at a very basic level, right? So I'll just go ahead. Like I said, we'll look at how the insertion of item at a specific position, right, and at the beginning of an array is quite different from how we insert at the end, right? So let's go to our code editor, and I'll use my playground to demonstrate that, right? So we'll first of all start with an array. Let's say we have an array of fixed size. I'll call this nums again, right? Nums is going to be equal to an array 1, 2, 3, and then 4, right? So let's quickly print this and see what it looks like, right? This is going to be equal to nums, and I'll print this here. Sorry. Okay. So we can see we have our array in the terminal, which is actually good. But so how do we add an item to the end of this array? To do that, I'm not going to use any built-in function, right? So to do that, we simply need to take we need to increase the length of our array, right? So the array has to increase in length. Okay, first of all, let me just do it with a built-in function. So we'll do nums dot append, right? Append let's say append a 5. This is how we add an item to the end of an array, right? And you can see 5 appears at the end of this array here. which means it increases in length, right? So how do we append, how do we add an item to the beginning of an array? And this becomes quite tricky, right? Let me just show you what this is under the hood. So let's say we have nums, right? Nums, nums. So we, the length to get the last item in the array, first of all, let's just do that. Nums, nums dot append. Oh, sorry. Let's print the last item in the array. The last item in the array is just simply going to be the length of the array, right? Length of nums minus 1, right? The length of the nums is going to be equal to so after appending 5, right, it's going to be equal to 5. So let me just print this here. I'll just print this here. I'll say let's just do it this way. I'll use this formatting, and I'll say the length of this array here. I just want to print everything on one line, so which is why I'm doing it this way. So this is nothing too complicated, which this basically means print on the same line, right? So in the console we'll have the last item of the array and then the length of the array, right? So let's just print this here. You can see this is 5 and 5, right? So this is the length of the array. Or I'll just say let me just say length equals to this. All right, so with this I think this will, okay, oh sorry, I misspelled length. It's supposed to be length and not length. So this is the length of our array. We have the last item in the array is going to be equal to 5, but we can't access an item at 5, right? If we do this, we will be out of bound. It will just say out, you know, we've gone past where we can access items in the array, right? So to access the item of the last item of the array, we need to do the length of the array plus, the length of the array minus 1. We need to use that value as our index to get the last item in the array. Now, instead of doing append this way, right, I'll just append the item like this. I will say nums. First of all, we know when we append an item to an array, it increases in length, right, or in size. So I'll just say nums, right? Nums dot so we need to increase the length of our array, right, in order for us to append an item to it. Okay, so what if we do it this way? Nums, can we do nums dot you see, len of nums will always return a value, right? I think appending an item to an array is basically like this. Let's say we add, I think we need to still use the append, right? Let's say we just append, let's say, an empty space. I'll just print this array again, right? Let's say we append this right, like a slot. Like a slot. This is going to be like a slot here, right? And I'll print this, right? Now you can see we have an empty slot waiting for us to add an item to it, right? This is what the append is doing. So we'll simply take the last item, and we know to access the last item in the array is just going to be the length of the array, right? Length of the array minus 1, and we'll replace this with our new value, and then this will just replace the slot here with a 5. Let's replace it with a 5. Now you can see we no longer have our empty slot, but we now have 5, right, as our last item in the array. And yeah, I think, let me see if this will work. I've actually not tried this before. So let's say we take the length of the array and we set it to 5, right? Would this work? Yes, you can see it won't work because we are trying to access an item where there is no item, because our array has a fixed size, right? If we're accessing 4 items in the array, right, item at index 4 when there are 4 items in the array, right? The last item in the array is at index 3, so there is nothing at index 4. So in order for us to get the last item, we have to minus the length of the array from whatever it was, right? So now, how do we insert an item to the beginning of the array? Well, to do that, it is also it takes a bit of steps, but first of all, we know when we insert an item into the array, we'll always have a bigger length, which means we need to add a slot, right? So I'll call this our slot, right? This is going to be our slot, and our slot is just an empty array, right? An empty string, or it could be anything. It could be 0, it could be anything, right? Instead of me creating a slot, I'll just directly do it this way. I'll say nums dot append, right? Append 0, right? Let's just append 0. We could append an empty string, or we could append 0. It doesn't matter, right? So the main thing to know is that whether we are inserting an item at the beginning or at the end of our array, the array will increase in size, right? So let's just print the length of this array now, right? Length of the array is going to be equal to 5, right? It's going to be equal to 5. This is the 5 value that we have here. So now, how do we append this item at the beginning, right? The item we want to introduce. Let's say we want to add a 0 at the beginning of this array. Again, let me just print this array. So I'll print the nums array, right? And I'll set this to be and is going to be equal to f. This is just a string formatting, right? I'll just take this and set the length of this array here. So I'll just say, okay, let's say length. I don't know why I erased the other one, but length is just simply going to be equal to len, right? Len here, right? So I'll just print this. So now you can see our array has a length of 5 and our empty slot is there, right? I can set it to anything, right? I can just put it like this, but we know after inserting an item, whether it's at the beginning or at the end of our array, we will increase our array in size, right? So here is what we're going to do. We are just going to I'll transform this into a function, right? Instead of having it as an array, right? I'll transform it to a function that accepts two parameters, right? So I'll just say define insert value in array in array. Yes. So insert value in array, and we'll set this to be a function that accepts first of all, we want the array, right? We want the array. I'll say okay, yeah, we want the array and we want the value, right? We want the value. Yes, for now let's just do like inserting in front of the array. So insert value in array. Yeah, so let's say, or let's change this to insert value in front, right? In front of array. So this is going to insert the value in front of the array, this array that will pass to it, and then the value will be here, right? So how do we do this? In order for us to do this, we first of all need to increase the size of our array. So I will say array, right? Array would then become array dot append. We can type this, right? We can set this to a list, I think. Right? We can set this to a list. Import this. So this is going to be a list. So when we do array dot append, we can append 0 to the end of our array, or instead of me inserting 0, I'll just put an empty, a straight line, right? So this space, we've increased our array in length. So what do we do next? First of all, we need to change the index of every item in the array. So we'll loop through the array for I in range. Now what we want to do is, instead of us you know instead of us directly inserting the item at this position, we first of all need to move this to the fourth place, because we know we are going to insert the item at the beginning, so it's going to be at index 0. So wherever index 4 was, right, in terms of index, we need to increase it by 1, right? So which means we have to start looping from the end of the array. So we'll start from length of the array again, right? So this is going to be length of the array minus 1, right, which is at position 4. And then we'll just do this. We'll take we want to stop at 0. We don't want to include 0. And then we want to step backwards by 1, right? So here's what we need to do. So we'll just say value of the array at position I. So array at I here is going to just be equal to array at I minus 1, right? I minus 1 will be 4. I will be 4 here, right? I will be equal to this, right? So we want to replace this with I minus 1, which is going to be equal to 4, right? Why is this here like this? Expected size got none instead. I'm sure, but type this, right? Do I need to put it this way? I mean, this will be equal to list of lists. Is this correct? What does it say? Wait, let me. You know what? I don't. I think. Wait, do I need to put that there? I don't need to, right? This can be the list. I mean, if this works, something like this will work in JavaScript, right? Because we can just set these brackets here. I need to tell it to this. But that's not the point of our video now. So this will replace every value here up to the last value in the array, right? So at the end of the day, we'll have. So let me just print the list. So I'll just print after the loop is done running, right? I'll print the array like this, and let's see what the value will be. So I'll just say print. Let me just call the insert, and then set it to nums, right? And let's call this. Oh, so we need a value at which we want to insert this, right? We don't need the value per se, because since we are starting, we want to set it at 0, right? But before we do the insertion, okay, so I mean, we need to insert a value, right? For now, we are not inserting the value, but I just put 0 here, right? And let's see what this gives us. Okay, so non-type has no len, right? Oh, okay, so what if I just remove everything, right? What if I remove everything? Object of type none has no len. Why is that? I mean, this is my array, right? Array to append. What's going on? I mean, nums here is an array. Typing is a confusion. Let me see, where do I have like an array? This an array. Okay, so you set a list. Oh, okay, so it's going to be a list, right? A list a list, and then we can now put something like this, right? Oh, that's not it. Do we do it this way? No, we don't. This is strange. But anyways, in order for me not to just waste, what's going on here? So we are looping like this from the length of the array. I mean, if we had our array, right, we'll just append. Oh, I see why. We don't need to assign this again, right? Yes, we did not need to assign that. Okay, so that was my fault. I did not know why I did that. So we simply need to append an item to the array. And at first, right, we'll have something like this. Let's print the array before. Let's print the array before. So you can see we had 1, 2, 3, all the way to 4, and then our empty space, right? But then when you look at the array again, you can see the empty space has disappeared. We replaced it with new values that were in the array previously. So what we need to do now, since we are inserting in front, right? Since we are inserting in front, the value here would have changed, right? So we simply need to replace this first value with 0, right? Or with the value we want to insert in front of our array. So to do that, we just simply need to come here and say um array at 0, right, will now be equal to our value that we want to insert. Now when we run this, right, this will be transformed into 0, 1, 2, 3, and you know, we can replace with this with a new value. We can put 5 in front, right? So in 5 in front, and the same thing goes for inserting at a specific position. We need to, you know, so if we want to insert at a position again, we simply need to change this with position, right? I'll call this position, and then instead of stopping at 0, right, I'll stop at the position where we want to stop at. And let's say at position 2, right, position 2, we want to have the value 5. Let's take a look again before we do that. So we'll have something like this, right? We'll have this transformed here, right? So at position 2, this will be equal to, you know, 1, 2. Position 2 will be somewhere here, so after 2, right? No, position 2 will be at here, right? This is 1 and this is 2, so position 2 here. So as you can see, we are still inserting at so this is 1. Why is 5 here? I would have 5 here instead. Where's my 1 gone to? Oh, so I'm inserting. Okay, so this will be our position, right? Yeah, so you can see we have you know, index 2. Now our value here is going to be equal to 5. So you can see the insertion at the beginning and at a specific point in the array is quite you know, it's not constant, right? In terms of type complexity, it's going to be based on the length of the array, right? So as long as we keep in, you know, re-indexing every item in the array, you know, until then, when we get to the specific position where we want to insert the item, right, we will just need to keep looking into the array, re-indexing every element until we get to that point where we know that this is the position where we want to insert our item in the array. And as of linked list, I will just, you know, advise you take a look at the implementation. Here it is quite simple, right? So first of all, we need to create a node, right? We need to create a node. So I don't know, this is the really okay. So I mean, this is already be created, but let's say for instance you want to create a node in linked list, right? So let's quickly do something. My time is almost up. But basically the node is going to be a class. So you create a class called node, right? This is your node class. And this class will serve you as what you will use to insert, right? So you can see the class is being instantiated here, and then each value is being inserted at a specific next position, right? So that's how it works. I don't know why they're not implementing the full thing here, and I'm running out of time. I can't implement everything, but you know, basically, basically, what you need to do is to create a class called node, and then you can, since this class is going to be instantiated every time, you will need an init method, right? This init method, and set the self dot. Now we'll set this as our data. We said before that the node is going to take the data, so we'll pass in the data here, and then the next value, right? The next value. So here our data is going to be equal to this data here, and then the next value is going to be none at first, right? Next value is going to be, so sorry, we don't need to pass the next here, we only need to pass in the data, right? Next self.next is going to be equal to none at first, right? And this is the class we will instantiate every time we are inserting an item into our linked list. All right, so that's it for linked list. My time is up, and I will come here tomorrow to continue with some examples, and we'll look at other parts of the linked list, and then try to solve some late code questions as well. With that said, this session has come to an end.